Welcome to SST's web presentation of checkstress for PDMS. The purpose of checkstress is to minimize the time spent going back and forth between the design department and the stress engineering department. It gives the designer a slimmed-down version of basic pipe stress analysis software inside PDMS that has only piping code compliance capability. This easy-to-use tool will quickly show a designer whether his model will pass or fail basic code compliance before it is sent to the stress engineer. This will then allow the engineer to focus on the more intricate areas of stress analysis, resulting in minimized project delay. In this demonstration, I will show you how to check your PDMS models for overstress. You will be amazed at how fast and easy this process can be and how much time and frustration it can save you. Let's begin. Let's look at a sample model. We start with condensate 00, and we see it has two branches. In the traditional process, this is the model the designer would send to the stress engineer. But let's see if there's anything wrong with this model. Once we have our piping model in full view, we can go to Info Plant in the menu and select checkstress. This opens the checkstress interface. Here we see that the interface has already selected the piping we're working on, and now all we have to do is select Add Current Element and apply. This will bring up the Analyze dialog. Click OK, and you should be able to see the model in checkstress. Now let's examine the model. Keep in mind you want to avoid anything close to orange and red color, as this indicates overstress. Keep your model cool blue. First, let's look at thermal stress ratios. Here the model fails. Next, let's look at sustained stress ratios. Here also the model fails. This is what the stress engineer would have told you had you given him this model. Upon receiving his corrections, you would have made changes and sent him back a revised model. This process usually continues through several iterations between departments. This can be fully avoided with checkstress. Let's select a revised model. Now we go through the same process. We go into checkstress, we add current element, and click apply. Now when we check the updated model, we see that the expansion stress is no longer a problem. However, if we look at sustained stress, we see that the model is overstressed. We can also see the sustained deflected shape. As you can see, there's excessive sag. We need to add some vertical supports. From here, the designer alone has the knowledge of the support steel to know whether a support can be located at a specific point. You make the appropriate changes and run checkstress again. Let's look at our final revised model. In this model, you will see that we have added some attachments. Let's look at those now. And let's look at one more. Now let's perform check stress again. Here we see that our model passes both expansion stress and sustained stress. Again, remember, you want to avoid anything close to orange and red in color, as this indicates overstress. Keep your model cool blue. As you saw, the designer went through one layout change and added some supports to arrive at a fully code-compliant model that he can now send to the stress department. What might have taken a few days of back and forth model exchanges now takes less than an hour. This ends our presentation. Thank you very much.